In the previous session, you were able to perceive the fact that whatever Java has been able to achieve is basically due to its features, and it is Java's features which has made it whatever it is today. It is loved by up to 9 million, that is 90 lakh programmers worldwide. Only goes to show that it is these features that those programmers have actually fallen in love with. But then, how does any programming language get features? In other words, if really Java has all of these features, then how is it that these features are supported by Java? Or in other words, what is the foundation upon which Java is actually producing these features, due to which it has become the #1 programming language, if I may say so? So what is really the foundation is something that I would wish you to know in this session. Well, let me actually put this session this way, that if there is a tree bearing fruits, then those fruits you can actually treat it as the features of a programming language. But then if there is a fruit, then obviously the root would play such a major role. Well, where is there a fruit without a root? And that way, what I would wish to tell you is that we need to find the root in as far as Java is concerned. Well, technically speaking, what I mean to say is that if the features are being supported by a given programming language, then it is basically due to its architecture. Well, it's a heavily loaded term, and it really would take some time for you to actually understand the meaning of this term architecture. But what I can now tell you is, like, what we have to understand is the foundation of Java, or in other words, the architecture of Java. It is only when you would maybe understand the architecture of Java that you would be able to understand these features, and then going ahead put these features to good use while you would be using this language to develop whatever you would be developing moving forward. But the point I want you to understand is that it is Java's architecture which has led Java to exhibit these features which have been accepted by programmers worldwide. And hence, if we have to start to learn Java, it is good that we start from trying to understand the architecture of Java. Let me tell you as to what the architecture really is. Java's architecture, or in other words, the way JVM has been designed, is what I should be explaining to you. Well, I have replaced one heavily loaded term, architecture, with another heavily loaded term called virtual machine, without explaining to you either of the terms. But the point I would wish you to understand is that if you are searching for that foundation, or if you are searching for that platform really on which Java has produced these features, then in other words, you are trying to understand the JVM. That is what it really means. And would you wish to look at that foundation, the JVM? Well, it's a pretty complex architecture. After all, Java is such a superstructure that its foundation really has to be very solid, right? So at the first go, when you happen to see the foundation, you could actually get lost in the foundation, and this happens to be the foundation. Well, I had already told you that when you have a look at that, definitely it's going to put you in a state of confusion because of the kind of terms that have been used in the foundation. Terms such as loaders, terms such as linker, compiler, interpreter, thread, stack, heap, a host of these terms obviously is the prerequisite for you to understand the architecture of the JVM. Or in other words, the point I want you to understand is that it is these terms such as the compiler, the interpreter, the object file, the executable file, the library files, and all of these things that you first have to understand if you really have to understand the architecture. And let me tell you that if in case you would not be able to understand the architecture, it means that to that extent you really would not be able to appreciate a given feature, or maybe really put it to good use. So the point I would wish to say here is that if we really have to understand the architecture, then it becomes important for us to brush up a bit of our basics. So very quickly, let me tell you all the details from scratch. If all of these terms have to be understood by us, then firstly, we need to understand the organization of our computer. Our computer basically consists of a microprocessor, a memory device along with the input and the output devices. In fact, all of this put together is what we call as a computer. And since 1956, we have been using hard disk as one of our memory devices. In fact, it was for the first time that IBM in the year 1956 created the hard disk drive, and since then we have been using it inside our computers. And initially, we used to connect the hard disk drive directly to the microprocessor via a set of wires, and this is what we referred to as the bus. Of course, the input and the output devices as well were connected to the other components present in the computer, but then for my discussion, since I don't need these components, I would just eliminate them from my discussion. Nevertheless, the larger question is, why do we really need a computer? Well, as I have already conveyed it previously, we need a computer to solve our problems by executing our programs. What kind of problems do computers solve us by executing our programs? Anyway, moving forward, I would definitely discuss elaborately about it. But then the question is, what is really a program? Well, a program is nothing but a collection of instructions. And where do we store the program? Well, we store the program on the memory device. The primary role of the memory device is to send instructions after instructions that are present on it into the microprocessor and get it executed. But then, just when everything sounded really good, we faced a challenge. What's the challenge? Let me tell you. The challenge was the difference in the technologies of the two devices. Well, if it's confusing, let me tell you that the microprocessor happens to be a semiconductor technology device and is an extremely fast device, whereas our hard disk was an electromechanical device which had a few mechanical components, and the speed of working of the hard disk drive was slow when compared to the speed of working of the microprocessor. In other words, the microprocessor could execute instructions at a very fast pace, but the hard disk was not able to supply the instructions to the microprocessor at the required pace, and hence the overall efficiency of the computer itself was reduced. Due to this, we decided to invent a new type of memory. We decided to invent a memory whose technology was the same as that of the microprocessor. In other words, we wanted a semiconductor technology memory, and we did succeed in the year 1968 when we invented the RAM. Yes, it was one Mr. Robert Dennard who invented the RAM, and since then we have the RAM present in our computers and is also directly connected to the microprocessor. The new memory which we invented had a lot of positive features. Firstly, it was very fast in its operation. Secondly, it used to consume very less power. It was compact, and it was almost silent in its operation since it did not contain any mechanical components in it. But then it had a lot of disadvantages as well. The major disadvantage associated with the RAM is that it is volatile. What it means is that RAM would be able to store the data as long as we would ensure power supply. If there is a break in the power supply, even for a fraction of a second, then all the data that is there on the RAM would get erased. This volatile nature of the RAM is one of the major limitations. Of course, RAM is also quite expensive, and due to these limitations, we had to look back again at our hard disk. Well, the hard disk had a lot of disadvantages. Of course, it was slow in its operation, it was quite noisy, it was quite bulky, but in spite of all of this, it had some good features as well. One of the important and advantageous feature of the hard disk was that it was non-volatile. It means that even if you will not ensure power supply for months and years together, still the data which is there on the hard disk would remain as it is. And also, it was quite inexpensive, and hence we decided that in our computers we would be having two types of memories. In fact, we started to call the RAM as our primary memory, which goes to show that the hard disk became our secondary memory. Well, there are many other types of memories present in our computer, and if in case this was a course in which I had to tell you about all the types of memories, definitely I would have gone ahead and conveyed it. But then at least as my learners, it was important for you to know about these two types of memories. Well, there are a lot of other terms as well associated with memories, such as the file, the byte, the register, the loading, the saving, and all of that. What do these terms mean? Let me tell you. file, byte, registers, all of this can hold our data. While file is a storage space available on the hard disk to store our data, byte is a storage space available on the RAM to store our data, and register refers to the storage space which is available on the microprocessor to store our data. Not just that, the process of taking the data from the secondary memory and putting it onto the primary memory is what we refer to as loading. And the reverse operation, that is taking the data from the primary memory and placing it onto the secondary memory, is what we call as saving. I'm sure now you've been able to understand the meanings of the terms loading, saving, and also have understood the main components of a computer. Well, in as far as processing is concerned, the microprocessor, this was our first generation of microprocessor, and then the second generation, the third, fourth, and the fifth generation microprocessors. Well, you can notice that as we pass through the generations, the clock speed is increasing. Well, if clock speed again happens to be a heavily loaded term, then I would tell you in simple terms that definitely the speed of computation of the microprocessor is increasing as we have progressed. And you know what? Today it is the case wherein we are moving towards quantum computing. Well, if you would wish to know more about quantum computing, then you can get it from this link. But what I would wish to say you is this, that say supposing you have an application, you have a program basically, which for execution would take 10,000 years. Well, and then if I would come up and tell you that, look, here is a technology which a program, the same program which would have otherwise taken 10,000 years to execute would get executed in 200 seconds. Would you be interested in such a technology? Well, that is quantum computing. Quantum computing definitely is the future, undoubtedly. But then what I would wish to say you is that we have come a long way from the first generation up to quantum computing. Well, that's definitely not a refrigerator. It is a secondary memory, a hard disk. And what's the capacity? Well, 5 MB is the capacity, and a whopping price for that 5 MB. But then that was in the 60s. By mid-19s, that was the case. And if you would now ask as to what the price is, well, approximately the price was the same. But then for the same price, what we used to get was a memory of a larger capacity, and obviously that was a 1 GB memory. Well, if you would look at it from today's perspective, definitely pretty bulky machines, because today terabytes of data can fit inside your pocket. So that way we have come a really long way in as far as the storage devices are concerned. Well, I'm sure you have been able to understand that the microprocessor is actually connected to the primary memory, but then if you want to increase the speed of execution, you can actually bring in the cache memory in between the primary memory and the microprocessor. In fact, we can have two cache memories, the level 2 cache and the level 3 cache, and really the organization can be something like this. Yes. Obviously, the hard disk is going to be the slowest memory, and that way I can consider the register which is there in the microprocessor to be the fastest memory. But still, what I would say is that the L2 cache represents the fastest memory. This can be the memory hierarchy, and you know what? That in this direction, definitely the speed is going to increase. The price also is going to increase, and if really this was a discussion about memories, maybe I would have spoken in greater detail. But now that you've been able to understand as to what really are the components of a computer, I just thought that I would give you some additional information to you as well. But then, you know what? We have actually started from punch cards and then moved on to magnetic tapes, and then the cassettes and floppy disks and all of that, and now our data is on the cloud. What does it really mean? Let me tell you. Well, if you'll ask me, what is all of this? Well, all of this actually shows the evolution of storage devices. For the time being, forget about all of this. Even before these devices existed, we had a device which was actually storing our data, and that way this I can call it as a device or an object which was used to store our data. Well, don't you recollect that during the school days we used to take down the class notes so that it would help us in revision during the tests? In many ways, the book was holding the data for you, and hence I can treat it as a memory device. Now, what a book was for us in terms of computers, I can say that it was the cards. And you know that in the book, we used to write and store the data, but then on the cards, we never used to write and store the data. Rather, we used to punch holes in the cards, and that's the reason why the card was actually termed as the punch cards. And then we moved on to the next level, which was the magnetic tape, and then from all of that, we moved towards the cloud. Well, all of the data that you have in your computer, do you think it's really there in your computer, or do you really also think that a part of it could be on the cloud? Well, I'm sure many of you know that already a lot of your data is on the cloud, and if this was a course on cloud, I would have definitely spoken in greater detail, but this definitely indicates the evolution of storage devices.